Okay, so my name is Ryeng, and I've been a developer for core NSO part for like 8, 9 years now. And just recently, I moved over to San Jose, doing more promotion and support stuff than before, and also presentations. And this is one of the first. So I had some feedback from my colleagues, and they said that you can't just jump into it. You need to explain some stuff before. And I try to do that. And please feel free if this is something that you feel is too slow or more importantly, if it's something that you don't understand, ask. I think that's the most important stuff. So it was mentioned NoNo Services a couple of times yesterday, and I felt that this might be oversold, and there is not that it solves everything, it's just one specific stuff, and that's in Reactive Fastmap. So I want to explain a little bit about what that is used for in the beginning. So you actually need to know Fastmap as such, and for me, I can't go any easier than this, I think, and that I think is easy, because with NSO, you have the ability to monitor a transaction from the inside. So when you have a create mapping call, you can monitor that from the inside and store the result, and that is done in the private data of the service itself. And what you store is not the things that you do, but how to reverse from what you did to the original state. So think of it as how you restore the devices from that state that the mapping did. And next step is that having that, delete is easy. It's just to take that stored data and apply it. Then you restore, then you deleted the service. There is nothing else. And update is also inferred in the way that you just delete, when you come to a commit with the service and you have the updated some parameters in the service data, you just internally apply the delete, reverse everything that you did before, then do the create, which now looks as this is the first time, but it has some new parameters and does the thing it should map, and then you apply that. And then there is one step more, and that is, since this is not the first time, there exists data on the device. So you do a diff calculation on what is the difference that I need to do. I can't just push that. I need to push the things that is different. And that is what we often refer to as the southbound diff calculation. That is what you push to the device. And I think this is actually the right abstraction for doing network services, the normal transactional network services. You focus on the create. You don't have to handle the really big problem when you have updates that explode in different behavior, the combinatorics of what you have to deal with. That is solved. And as Stefan and Victor said yesterday, this also comes with a lot of things that you can have without thinking about it. And it's like redeploys and dry runs. And a redeploy, when you look at that at the first time, it looks something like something that's not necessary, because what it does is that it executes the update without you having updated anything. So it just fakes it as an update, removes everything of the device mapping, calculates it again, and calculates the southbound diff, and that should be 0. So the outcome would be a no-op. But not always, because there can be code here that does something, that looks in some operational data or whatever that does something. And it's a very neat way of doing software upgrades. You can change the code, you can do a redeploy, and the new code will do the new thing, and the only thing you push into the device is the new settings. The thing here is that you can also do not just redeploys, but any commit as a dry run, and you can see what would happen if I did this. And that is also something that is very useful. All of this comes with one thing. You get this for free, but you should never put any side effects in the crate. It should be a straight mapping for a transaction. As soon as you start waiting for stuff, calling RPCs, doing stuff like that, you are on your own, because the problem is, if you do a dry run, should you even call this RPC? Should you still wait for stuff? Should you still do all that? And the answer is no. And you won't get a beer, I think, if you remember what Stefan said. So don't do that. So that gives you get a bit stuck then if you actually have use cases there where you have to wait for something. You have to call an RPC. It doesn't really help you with this elegant Fastmap thingy. And that was why the Reactive Fastmap pattern was introduced. And that is also like 5-6 years ago. And that was to solve this issue that if you code this in a certain way, you can actually break up the crate call. And yeah, I'm a bit forward. So what you do is you break up the crate into conditional stages. I regard this as you start looking at the crate as a lot of cases or if statements that you check that is this condition met, is this condition met. And the thinking is that you do the first step. When you have to wait, you leave that transaction, you wait outside, and then you redeploy, this elegant redeploy. That will start the transaction again. It will tear everything down, put it back again, but the first part that it puts up is the same thing as before, so that will be a no-op. But then it will go further, and that will be the new stuff. So this is the loop, the reactive loop then that you can use to be able to do waiting or calling stuff. And that is the other thing. That's the pattern part of this. Not only the structure of the crate, but you actually need to have something. Normally this is a CDB subscriber, but something that makes the service self-sustained and converging. And that is the thing that does the redeploying and does the waiting and does the calling or RPCs or whatever. So I like to think in pictures instead of slides or bullets. And so this at least works for me as thinking of it. These are the conditional stages for the service. And at this point, it has just been converging to the first part. So this stage might have been done. Then you are waiting for something. That can be a notification from a device itself, or it can be something from whatever. And you have a CDB subscriber that picks this up and then decides that, well, now I can redeploy the service. That's the only thing I do. I do a redeploy. Or actually, you do something called a reactive redeploy, and that's used just for this reason. And the difference is that it actually also is consistent with the last transaction parameter. So if that last transaction was a commit queue transaction, this one will be a commit queue transaction. It will be done in the same user space and everything like that. But that's not the important part. So this is what's happened. And this was what was implemented, and what immediately was found out that when you start to do this and maybe some other services, because normally a deployment has more than one type of services, you start to get into the problem of, this service needs 5 redeploys before it's converged fully so that it's completed, and another one needs 10. How would I know what the state of this service is? Is it the only way to look and know what the data is that it should do? No, you have to invent something. So you invent some operational data or something that you can look in that says, hey, I'm ready or not. And that is from the programming view a nightmare, because then if you have an OSS or a BSS and want to look at services, you won't know where to find the data, or it's different for every service. So something called plan data was introduced. And it's nothing much. It's a structured data set that is generic. So you know where to look at it and how it's structured. So you might be able to program something that knows when a service is converged. So I think it's easier to go with the picture first. So what it does is that it is structured in a way that you have components, and components have states. And this is something you decide yourself for your service. What is a component? I might have a really big service, a lot of states that I spin up a couple of devices in different ways. And then I might want to have a component for each of the device, because their life cycle is different. So I want to see which device is spun up or not. That would be a component. Or anything else that you structure. The only thing that is stated necessary is that we know what the first state is. That should always be init, and the last state would be ready. And you need to have a self component. You need to have a component that you know the name of, otherwise you wouldn't find anything. And that one also has an init and a ready. It can also have something in between. For really simple services, you might just want a self component with some states in between. But the important part is that when the self's ready state is reached, then you are fully converged. So that you have. The rest of this is logging, so that you can say something of, is this failing somewhere, and where is that? And for that reason, you have 3 states, 3 statuses for every state. This is a hard one. State is the thing, status is what it is right now. And that is not reached, which is when you start, and failed if it fails, and reached when you are going further on to the next. So this was introduced, and the only thing in this scheme was that you have to write the plan too. That is data, so you have to write that while you are doing this convergence, doing this staging, you have to write this and put it right. So this is also one place to do it wrong. And if you log wrong, you think you're wrong. So this is actually a bit of a problem. Or I think it's a bit of a problem. It might not have been a problem in reality, but yeah. So now everyone said, but you should show how this looks like, and I'll do that. So when you say Reactive Fastmap, you expect there to be at least one CDB subscriber or some process outside, and you expect to find a create service which is partitioned somehow. And this is the create service for something that is almost something we have. It's not that much cheating. And it's a create call in Java. And it isn't very easily seen, but the staging here is that you call something to allocate IDs twice. And you wait for them to be, you get them back, because they are put in the data tree somewhere as operational data, but you don't know when. So every redeploy will check this, and when both are set, then you push this to the device, the config. I think this is the push part. So it wasn't even easy to see how it was partitioned, this code, but it was. And this is the actual CDB subscriber for this. This is the thing that waits for 2 operational leaves to be set and push a reactive redeploy somewhere here. Yeah, and it needs to do it in a thread, so it's a redeployer thread here also. We do CDB subscribers all over the time. They are great, but you need to do them from scratch. There is nothing much help. We talked about Fastmap being the abstraction that is necessary for a normal service, a one transaction service. This is no abstraction level at all for the reactive. You have to write that by yourself. And that would be good and well if there wasn't more challenges with reactive Fastmap than this. And that is that I've just talked about this as something that is going forward. It's like a crate that is staged. It's going forward to the end. But that's not the case. The life cycle of any service is bigger than that. You might have some scenarios where I converge somewhere, but now it's not that easy anymore because the device crashed. I would do something else. I need to spin up something else if it's a virtual function or whatever. And when it comes to deletes, then it really gets hard because, as we said, deletes are inferred immediately from Fastmap, so you don't get any help. For Fastmap, the service delete is something, hey, I can do that. So you can't really stage it. So what you end up doing is that you tend to have a more complex CDB subscriber, or you'd end up with having more than one because you have some other data set or some other service that's used as a facade just to be able to delete something while the real thing is not deleted. It needs to be doing less and less for a while before it can be deleted. And so then you start having something like this. The real service, it might be hidden for the customers. You say that the facade doing the job, and then you have to monitor both of these and all the other stuff. And it starts to be pretty messy. And the more messy it becomes, the more easily you have situations, scenarios, which you don't cope with in the code. You haven't thought of them, or there might be something else here. So what is the real problem? And now I think we'll do a short deep dive to explain why NoNo services are better or can do this. Why are they needed? The thing is that you would like to have something that have this type of lifecycle support natively, that thinks of this, that you're doing this in more than one transaction. And you would also we would prefer to have something that is not spread in a couple of CDB subscribers and the service code, and they interact in some way. And the idea with NoNo Services is that the CDB subscriber, they should go. You shouldn't need that part at all. And in NoNo Services, you do this by declaring sort of the plan and the life cycle. We will see that. But this is the same example as a NoNo service. And it's sort of the same size of the service code. It's partitioned with, this is one call. It's called create here with its declaration. And this is another service. The only difference between those is that they have different states that they say that they are executed on. So this is actually two small services doing their part of this big one, the big service here. The code is almost the same, but that's sort of what it needs to be. It did the job before, it needs to do it now too. The difference is instead of the CDB subscriber, you now have a declared plan, which is this part, a plan outline. This is the self component and then the other component. And you have a behavior tree. We will go into that too. But this is what's done instead. And what is done with this? What can NSO do with these declarations then? So you need to compare this a bit, or I think this is fun. Maybe it's because I think this is fun. So what you do is that you execute the plan. You had this plan. We turn it around. If the plan is important, let the plan decide what to do. So that's what you do. You start with having a plan. And you want to have a self-sustained reactive fastmap loop. So something will know if it needs to be redeployed. And that something is the kickers that were introduced a couple of releases ago, or maybe 4.3 or something like that. It might be a long time. Super short about what a kicker is. So the difference with a kicker and the CDB subscriber is that a kicker can just do one thing. It can monitor and execute, invoke an action. A CDB subscriber can do a lot of things. But the important part is it's only declarative. You write data in a transaction, and when you commit it, that is a kicker that will monitor and invoke action when something happens. So the next transaction and all transactions after the one writing will monitor this. And even more interesting, if you remove it in a transaction, you will no longer monitor it. So you can decide when something happens, just now I want to do that. And that is key in using for NoNo Services. So I'm very keen on pointing out the differences with the traditional Fastmap approach and NoNo Services, but I have to point out that the idea here is that the NoNo service is a real service. It's just the implementation that is different. So all the things that you got for free, they are still there. Normally, as a consumer of this service, you do the things that you did before. They are all there. It has a plan, you look in the plan, you don't care how it was implemented. This is for our guys. We are the guys that want to be sure that it works correctly. And looking at this picture again, this is actually just pointing out, we had all this before, but we pointed out that if we do redeploys, we just execute the create callback, and we do more, go further and further into that. But what we do is that we calculate, the Fastmaps dictates that we calculate the reverse diff set of this mapping. But it just put it there. So we do more and more, but we just get one diff set. So we don't in the end know how many states were there, were all of them done, or were some not done yet. And that is the big problem, that, for instance, when we delete, we apply this one. We can't stage that. We don't know which stages belong to which part of that. So that is what happens, and that's maybe the name came from. That was trying to say that we want to break up the service in smaller parts. We can't say microservices because then everyone will think of something else. But the thing is that if we execute the plan, we already have this data structure, but now we put the Fastmap service data inside every state and a little bit more. So then we have the reverse diff set for every state. So if we execute a part of the device config mapping, we have the same part of the reverse diff set where it belongs. And the other thing that is very important, that for every state now, we dictate a precondition. Instead of having a CDB subscriber that says that, oh, something happened, I redeploy. We say, to get to this state, this precondition must be fulfilled. And if it isn't, then I create a kicker and wait for it to happen. And that's purpose of that kicker is only one thing, the reactive redeploy. That's the only action I will ever do. So this is the way that it becomes self-sustained. all these components are executed in an orderly fashion, and that is just to try to keep the meaning of the Fastmap algorithm. We still try to enhance to the Fastmap algorithm, but be true to it. But every component has its own life. They are independent. So when you execute and you stop here, if you had another component, that could go to its fulfillment for that component. It doesn't need to wait for another component, at least not necessarily. If you declare a NoNo service, if you had this before the normal, that will not be invoked. It will not just care about that code, even if you try to do it. However, as I said, it is a normal service. So if you had pre-modification or post-modification, they are called. So it's just the implementation of the create and the CDB subscriber that is changed. So we execute this plan and we store the data set. And what is the neat thing about that? And the actual thing is that we can now control, as I said, we do it in an orderly fashion. It's an order by user list. We do everything as it says, but we don't need to. If we choose, we can do it any other way. And the only other way that we are interested in doing it is the reverse order. So if we regard, as I said, one component as something independent and someone, let's take that slide. So when would we be interested in reversing the order of a plan and start deleting, doing applying the reverse diff set, removing data from the device? One would be if someone somehow decided that this component that I had before, I don't need it any longer, I don't want it. Then we can't delete it immediately if it has config. We need to backtrack that, and that's the name that I missed. The process is called backtracking. A component is backtracking. So doing that, we can be staged that way too. It isn't necessarily that I jumped out to that, but there were a delete precondition that you could set also on the state. So when you backtrack, you have the same possibility to say that, yeah, I can delete stuff, I can do the apply reverse diff sets for the states, but I need to wait for this to happen. And that is usual for reactive fastmap loops. You need to do something also when you delete. It can be licenses that you need to recover before or something. So that is one case, removing a component. Another one that you might not think of that much is that if I have all these preconditions and now when I'm executing forward, I find out that what earlier was okay is no longer there. I can't fulfill this contract anymore for this state. But I have already run through it and done the config for that and maybe another state and maybe one more. Then the only way I can deal with that is to start backtracking, going back to this failing state and wait for that to be okay again. And this is actually one of the most important parts of having automatic lifecycle. This is one of the things that are hard to do in a CDB subscriber. And the other one is if the complete service is removed, then all components should be backtracked. Okay. So these are the primitives. So these are important. You need to think about these when you do a NoNo service. It's good to know what happens. So I think it's best to do it in pictures. This is some artificial service that is a NoNo service that executes and have two components. It's in the forward way. It's almost there. If this state becomes reached, then we will be reached. But now someone decided that this component should be removed, the A component should be removed. So it starts backtracking, it starts removing the diff sets. It hasn't done this, and that is probably because there is a precondition here that says that I have to wait for something before I do the complete delete. So it does this in an orderly fashion, and not before the last or the first state is. And in this sense, if we are going this way, we want to be reached. If we're going this way, we're waiting for the status not reached to happen. So when this is not reached, it is removed. And then the plan is fulfilled, so then the service is converged. The other one, starting with the same thing, the service is almost there. And now, when we do a redeploy, we find out that this precondition, it isn't there yet anymore. So we need to backtrack. We need to remove the stuff that we did that we weren't allowed. We are no longer allowed to have it. We were allowed, but no longer. And then, boringly, still we can't do everything in the same transaction. We have to wait for something, but we still want to do this. So the goal is to get there. So we just wait for that to happen. And when this has happened, then we are done. Now we are in a good state. This is what we want to be. So we can move back to going forward again. And this can happen in the same transaction also. If we go this way, we found the goal state, and we find out that now this precondition is set, then we can go further in the same transaction also. That's no problem. And then we have the baby of sorrows, when we delete the complete component and we want to be staged in that delete. We can't remove the complete service in one go. But we still need to remove the service data, because if someone doesn't exist on this service, someone must say that this has gone. So this is solved by moving the service data and the plan into a zombie. So there is a zombie list where you have the service as a blob and you have a plan. And the same thing as before now happens in a zombie state instead. And the only thing you want to do is to execute backtracking on all the components until you have removed all the device config or the mapping data. And as soon as every component is done, you remove it. The last one to go is the self, because you will always need to have the self to check if it's okay or not. And when it's done, the zombie is removed. So it's a nuisance, but you need to move the service data. You need to move the plan somewhere outside of the service, because you need to remove the service. Okay. So this is how NoNo Services deal with all lifecycle events. And if it's enough or not, we don't know, but we haven't found a reason to have more than this. And for sure, it's deterministic. It does exactly what you want. There is nothing that it does more or less than the preconditions and running this code. But there was something else, and that was, it isn't just the precondition. It's just not just waiting that you do in the CDB subscriber. You do a lot of other stuff, and you need to be able to do that too. And as we said, you can't do any RPC calls, you can't do any actions, anything like that in the NoNo service crate either. You will never be allowed to do that. That will never be a bear. So instead, there is one more declarative part. You can state an action for each state that you say that after the state is reached, then I asynchronously would like to call this action. So just call it, and I go further. And that is done by, in this transaction, it writes this to a specific queue and says that, well, when this transaction is committed, please execute, invoke this action. And when that is evoked and either it failed or it's, in this case, reached or successful, there is another status that is updated that says that this has been fulfilled. And then What you do if you're waiting for this action to, then you set the next precondition to my previous neighbor's status. I will need to wait for your post action to report its result before I go further. And this is how you break the transaction with an action. You can even break a transaction without anything, as I've been told. If the action is a no op, just return true. This will still break the transaction. So if you regard this as config, but the device needs to do it in 2 transactions, this is the easiest way you can do it. Okay. And then I just briefly mentioned that there was a behavior tree part in the declarations. And that is, if we now can declare the plan and tell the NoNo Service Manager how I want the life cycle of this Reactive Fastmap loop to be controlled. How can I control if I want to change the plan? And we want really to be declarative here too. And I think I skipped to the picture again. So what you declare, the thing that I showed you before, the Yang, that was the plan outline. So that is every state in every component and all preconditions that is necessary. And if there is a need for a callback or if there is a need for a post action or whatever. And the plan outline, that is like the class. I don't necessarily need to have all these components types in my plan. Or I might need to have more than one of a certain type in my plan. This is just the scope of the components that I need. The only thing I'm sure of, I need a self and only one. And then there is a behavior tree, and this is like the 80s AE expert shells that had a decision tree. So it's just, for the moment, there are 2 types of control flow nodes, selectors and multipliers. And what they do, they just evaluate stuff. They can have preconditions and evaluate them. And if they are true, then they say, let's evaluate my child. So it's just a tree that decides to go further into the tree. And the leaves, they are create component leaves. So the leaves are the only nodes that do something. They are action nodes. And what they do is that they choose a component of the legal ones and give it a name. So this is, instead of coding, you make this tree and you specify, a selector is like specifying, I want this, I want this, I want this. And the other one is a multiplier. Then you have an XPath. Yeah, and by the way, this is all XPath. Yeah. You specify a node set for something and say, for every element in that node set, I want a component. And I name it this way. Then I need to have something separating it, and that would be the name. So this has to be done a lot of times because this can be done, or it is done for every component that is finished in that loop, in that redeploy. And that is because we really want the dynamics of that the service itself decides that, oh, now this has happened, then I need to spin up something else, or I need to do something else. And this behavior tree can do that. And it can take it away, and taking it away is just not writing it anymore, precisely as Fastmap does anyhow. I don't say that I want it anymore. Then it will become backtracking and be removed from that point on. Doing this is called synthesization, and this is the real plan I get. So actually from this, I have a selector that selected self. This had a precondition, but it was type A, and that was never used. So this precondition must never have been applied or fulfilled. But this one is. So there is a node set that had 3 elements that the name was LM1, 2, and 3. So it became 3. So that node set, if that change and I synthesize again, it will be more or less or the same depending on what's now in the next transaction. So I think the picture is better than this is how the tree is constructed, that only the leaves can do something, the other is just control nodes. Yeah, I think it's better to read the Yang actually for this, or doing it to understand it. Think of it as a declarative way of deciding which components are part of a plan. What do you say, Simon? You look a bit... Then I'm... Okay. Yeah, so how do you do this? You still have the same service point as before, it's a normal service, but you must change the plan. If you are using plan data, you need to change it, or you need to use nano plan data. That is the same structure, but with all the adornment or the decoration that you need for a nano service. So that is necessary. It's more or less defines it as a nano service when you use that grouping. And then you need to have the Yang extension used to declare a plan outline and a behavior tree. So you really always need to have a behavior tree. But for all static plans, you probably don't need to be that dynamic for the most part. Then you just have a selector and say, I need this one, and I need this one, and I need this one. And then that's done. That's a done deal. And doing this, in the end, you will be better at XPath than you were before. It will. I don't know how many times I have read the W3C standard. I still don't get everything. Yeah, looking into this, the only difference from what the normal service would be that it might have used plan data. I changed that to nano plan data here. Otherwise, this is the normal service. Declaration lists something doing a service. This is the outline. I have a self component. It doesn't really do anything, I just need it. And I have another component that actually does stuff. It has an init state. The init state doesn't even do something in that, it just reached immediately. And then I have a dev setup that calls something. So this states that I actually register a callback, a nano callback, and do config on that one. And I have the ready state that have a condition, some condition, and a delete condition. Actually, this is the normal example that we have, and the conditions here are the interesting part, because this one states that it can't be ready before a certain flag test passes through. And this states that it can't start to be removed before another component has taken my place, and it's okay. So it controls if I can delete something so that something new is there before. So it's a create before break. And the behavior tree here is a little bit more complicated. It has a selector with the self component, that's easy. And then it has a multiplier, and that is that it takes the endpoints and create components with a certain name. It just concatenate stuff. So this is how you could have more than one of these components, which have the controlling that it can't delete something before something else has taken my place. So this is the control, the part that says that I actually can have more than one. Okay. So I gone over time. It's 50 minutes left. Or? I'm on. Yeah, so
you still have it's 9:45. You have until 11.
Oh, I have to 11. I'm too fast.
And I think you were going to have
There is no questions. Okay, thank you. I've never been this fast. Okay. Yeah. So then a bit of history. This was introduced as an experimental feature. It was a research activity. in engineering, and I think it was 4.3 that it was introduced as a experimental feature, because we thought that we need actually some input if this is something that can solve real use cases. As someone stated before, we don't really want to do stuff just. We don't want to break the Fastmap paradigm, and we really want to do stuff that someone needs. So we weren't certain for that in this scenario. So we said that if you do it experimental, someone might pick it up and look at it and think it's good and say that what's bad and good. And it stayed that way in 2 years. No one picked it up before Mandus did, and Simon. So that was the thing. We have this really big reactive fastmap service that is called NFVO. It's a function pack, but it is also a service. And it is a real use case. And they used NoNo Services to do that, to replace the other loop that they had already. And found a lot of things, but the most important part was that the algorithm and the lifecycle handling worked. That was the thing that's most important here. So now it was released in 4.472 as something that was just a sneak release because it was needed for the function pack. And it was re-released now in 5.1 because we wanted to say that, well, this exists now. It's not normal that we do this type of thing in maintenance releases. So please give input if you use it, if you have problems or see something that it would be that's missing. And we have a backlog of stuff that we will need to do. First thing everyone complains about is that it is hard to debug. There is a lot of XPath expressions. They have to be right because otherwise it breaks that way. And there are actions running in the queue and stuff like that. And we will need to do more of that. I wouldn't be standing here if I didn't say that debugging tools is necessary. Rebecca would say that. Now you don't have to say it. Yeah. The post-action part is becoming more and more of interest. So there is certainly things that we need to do there to have more functionality to control them. Since this was released or the experimental, there is now something called notification kickers. They are not part of these declarations. So if you need that, you need actually to fake that by doing that writing, that configuration as part of your NoNo service crate. And that is boring and maybe even error prone. So that would be better to be put into the declaration part. This is all declarative. I'm not the guy to do it, but it feels like this should be able to be drawn instead of written. And it would be one-to-one. You could pick up a YANG file, see how it looks like in a tool, UE tool, and you could then do modifications. So for development, it should certainly be possible to do something like that. And there is no way to say it softly. XPath is hard. But you need to have the same paradigm as kickers are, and they are also XPath. So it goes hand in hand. Kickers are also hard then. Don't just blame NoNo Services. The thing is that there have been discussions. There are two ways to go. Either you change how you declare kickers and do something else, or you improve in XPath. That makes some, you have some declarations there that is more human to write. I think all of this will be addressed at some point. I don't have a roadmap for anything of this. The more it will be used, the more it will be focused on. It's still, I think, your group with the function pack group that is mostly into this. And please check it out. There is a lab. I think that some of you might go to the lab this afternoon. That we try to remove the CDB subscriber, or at least do the same thing as the RFM lab did, but as a NoNo service instead. Okay. I don't have anything more. Either we take questions on this part and you while we prepare for.
Try. If we're going to take questions, we're going to do a pass around mic.
Yeah.
Do you have time for questions before your next
Yeah,
associate comes up?
because otherwise you have 1 hour and 9 minutes. We could maybe have the break too.
We could. Do you want to take questions now before your associate comes in?
Yeah, so let's have the questions and have a break, and then we can set up you. And because you don't need more than half an hour anyway.
Okay, I'm going to walk around. We're going to do it on a mic so we can pick it up on the recording.
Yeah.
Thank you. Yes, so I have 2 questions.
Yeah.
The first one is probably pretty simple. You said that it was released in 4.7.2 and then in 5.1.
Yeah.
Is there any major difference between the 2 versions?
None at all.
None at all?
It might be a bug fix, maybe, but nothing functional.
Okay, so that was the simple question.
Yeah.
Yes, so the idea of all this is to have a service to be able to wait for stuff that can happen. The question is how long, on what am I going to wait? Is it correct to have a service being in an intermediate state forever or for days, or is it just for minutes?
It doesn't, characteristically for NSO, it doesn't matter. The only thing you will have is that you will have a kicker. So every transaction, that's what a kicker is. It's a data set that says that if you are in this part of the tree, I want to have a say. I want maybe to invoke something. So that kicker will be there for the time, the duration, but it can be forever. That's not a problem.
Okay, so in your opinion, it is okay to use this to avoid using a workflow engine on the top of it?
Yeah, that was the question I wasn't prepared for. But the thing is, yeah, it is. But we don't do user interaction. So the thing is that it wouldn't really make sense, I think, to do post actions that start to deal with mailing or poking someone and saying that you are not in the right process here or something. I don't know. But it is a flow. It is controlled that way. And there is no characteristic that it need to be now. I mean, it's developed that way because you can't have transactions running in user time in that sense. So yes, but I don't know where the difference go. And I probably should, but I wasn't prepared. So I think that what Stefan said makes sense. If it's a business flow, use the stuff that they want to see. If it is a service network stuff, you shouldn't use a workflow. But if you feel that you have something that is workflow-like for network services, you probably can do it here instead.
Thank you.
Okay. Yeah, question? Yeah.
Thank you. Couple questions. What is the scale? How many can we have sitting in a system before it starts bogging down? What is the cycle that's going to...
I don't know.
Okay.
But the thing is that we have situations with many kickers, at least. So one thing is that when does the number of kickers make transactions slow? And I don't have that answer, but I haven't really seen the situation where we needed that yet. What we can do, is when we start looking at the services as they are, it's very easy to do XPath expressions that are slow. And this is very sensitive to that then, because it will re-evaluate this bad or any for that.
What's the period for re-evaluation?
That depends on how many kickers. it's like I couldn't converge now. I have something to wait for, and then I do the redeploy. So it depends on how many kickers, and that would be like one for every component that didn't get to ready state. So it isn't like millions for a service, but if you have a million service instances, it's more.
So the last, would this be appropriate for, say, like a final service activation when a port comes up at a route or something to that effect?
Yeah, I think so. I think so. I mean, it's for anything that you, for instance, like to pre-provision like the service, but you are not ready to do it in the network already.
Right.
And I don't know. I mean, I have already seen that there are stuff you can do with Nano Services that aren't really the major reactive Fastmap loop that you discussed, because we are very much into the cloud then and very much into virtualized network functions and stuff like that. But just the case that you have a device and you would like to model your service this way, I don't want to care that I can't push all this config on the device in the same time. That's something that's just part of the device, and this device can do it. Then the Nano Services can break this up into different components for different device types and do this no-op thingy I said, that just waits for that to push that into two. And that's not the normal case we did before, but it's possible because we just have this opportunity here.
Thank you.
Okay. Let's see. Who's in back here? Okay. Let's Hero, why don't we go you, and then we'll go you next at the front.
Thank you, Troy, for the session. That was really useful. And I think the power of this Nano service is when we would like to do the staged deletion, right? And I'll build a lot of code by using old way that that I can delete everything at once. So even for that kind of scenario, do you recommend using this Nano service because this is very declarative, or
Yeah,
it's okay to use it all the way?
I would love them to be used always. The most thing I've heard is that they are hard to understand how to use, and therefore I've tried with this presentation to at least explain what it is. So that's one thing that might hold it down. The other thing is that I don't know. It was developed for the use cases like explicitly for things like the NFU. But what we see is that there are other use cases that also, and it's not necessarily that the stage delete is the problem here. As I say, it is hard to write from scratch something. A CDB subscriber, I start with nothing, and I think of everything, every single situation that comes in, and handle that correctly in the normal service. So with this can be wrong, but you can find that in the declaration. I'm not waiting correctly for the stuff that I need, or I don't guard this. And the thing is that, and that will be in the lab too, it's just, the lab will try to just mimic, at least in the beginning, a real service that has a plan that was a log. Just execute the same. But this is programming. The programming isn't easy because doing the declarations is the programming that the CDB subscriber was. But it does it the same way all time. So it doesn't miss anything in the same way. And if you need more things to think of, you extend the components with new states in the plan. You can wait for as many things as you want, but you need to have several states to wait for different things.
Understand. Thank you.
Okay. You're great. Bring it up.
Just to clarify what I thought I heard you say in your answer to the question before last, were you saying that kickers get continuously kind of repetitively evaluated, and the polling interval just kind of depends on how long it takes to evaluate all kickers in the system?
No,
or?
not really that way. The kickers are there. So every transaction that goes through MAPI, and MAPI today, and that's, I had it in the slide, but I didn't mention it. This breaks if you write data with CDB sessions. From now, the modern way of doing this is that even operational data is written through MAPI. Then it goes through the transaction engine, because the CDB sessions, they go through the database only. They don't go through the transaction engine. And the transaction engine knows that, oh, in this point, now I'm in the part of the tree that I have kickers for. Then I need to evaluate them as the last part of a commit. That's what I do.
So I get that with config data, right, you only have to evaluate it upon commit, but since operational data is always changing, is there a way to specify like a polling interval to check operational data, or?
So if the polling operational data is also written with MAPI, even if that is, so then it will be automatic in the same way as config. So it depends on how that operational data ends up into CDB. So if it's done the new way, so to speak, with a MAPI transaction, then it will be perfectly. Then you don't need to poll anything. You could certainly poll. You could certainly have some kicker that pokes a service. And if it breaks, I said it's self-sustained, but if there is something, a bug or something we missed here, then you need to poke it. What you poke with is, do you do a reactive redeploy action yourself, and then just kick it in the butt and it will go on again.
And just one more quick question. I'm sure you covered it in the plan before, but I missed it. So each component doesn't have its own service point. That's just at the top level, and then the component in the precondition explicitly calls an action somewhere in the CDB tree. Is that how that works?
Yeah, so the registration of your NoNo service is the service point and the plan component state. So in this state. And it's twofold. You have to register it, and you have to specify it in the plan outline. And the specific reason for this is that it isn't as easy as before, because before we could warn and say that you shouldn't do anything on this service now because you haven't registered the vital create callback. It's equally vital that you have all these NoNo services, but there are no more, not just one. So then you need to say, the service manager need to say, yeah, I have the correct set of NoNo services registered. I can do this now. Otherwise, I have to warn.
Thank you.
And also, I didn't mention that, but I have so much time. Let's go back all the way. This boring way. It was in the beginning. Yeah. Now it's we're backtracking the complete. Okay. So you register all of these, and they can be many if you have a big loop. You don't need to have the same daemon for all of these. So that's the neat thing. You do that normally. If it's Python you like, you have everything in Python, you have it in one module. But you don't need to. You can have someone that are templates, others that are Python, and a third that are Java or even Erlang if you like to do that instead. So you can mix. That's not the problem. And it's also so that the thing that you almost always see with the Reactive Fastmap loop is that you have a Java or Python apply template calls, because you need to do something before you apply the template. You can't do it often breaks to have it as a service. But the apply template, the internal service template for NoNo Services, it takes account of all parameters, all the opaque variables that you have all along the service. So now you can, for instance, in the init of everything, you calculate every parameter you ever want to, and then you can have all the templates just using those parameters, and then you don't need to have all these boring apply templates in every NoNo service. So, and I recommend that way because then you don't have the context switching all over the place. If you can do a template, it will be faster, because there is nothing I said here that implies that NoNo services are faster than normal, because there are a lot of context switching. It's just that it might be more controlled and it might be less error prone.
Troy, we do have another question for you as well.
Yeah, sure.
Over here.
Patrick? So my question is about a recreate scenario. Can you do recreate at a component level or at the service level? As in, say, for example, the VNF, a VNF create request has been sent out, but some parameters have been sent out incorrectly. It's reading it from the VNFD, for example.
Yeah.
Now the user goes and corrects the VNFD, figures out, okay, I'm,
Yeah.
mistyped or did whatever, right? Made a mistake in the VNFD, fixed it, tries to recreate the VNF. So do they have to delete it and then create
No.
it again, or is there a easier way of doing it?
So no. So the thing is that if the recreating is coming from that you are converging and you change some service data, then that will be taken care of by the Fastmap loop, because there is a big Fastmap loop here. It reverts everything and it actually do everything once again. So that will take care of the first part of that. Yeah. Yeah.
However, if it's reading from another tree, say for example catalog or a VNFT or some separate tree which is
Yeah.
bigger than the service tree, then is there a way for us to achieve that?
Maybe the only thing that I can think of right now is in the behavior tree, the one that decides that I need this component. There you can state also that I want an observer. And that is, if I create this component, I want someone to guard this always, because I might want to remove it or anything. It's just a redeploy. And that is a kicker that you actually do. You say that it's not enough that I just create this, I need to guard it. And that might or might not solve it.
Okay.
Yeah.
Try, we have another question
Yeah.
from Jay in the back.
Hi. Well, two questions really. I'll try with the easier one first.
Yeah.
So when you have a Nano service, you have various stages. In some cases, it's a complex one where you got VNFs, and then maybe the final stages, you want to push some configurations to the VNFs, and maybe also the physical devices. Is it possible to control the kind of the commit flags, like no overwrite or commit queues, etc., as part of that?
It will, the only, no, but yes. Since its driving force is the reactive redeploy, it keeps the commit parameters that was in the beginning. So it's the same user, it's the same commit parameters in the end. So if you want to change that, there is no way. What you could do is you could infer a normal redeploy with new commit parameters, and that would reset the reactive loop. It hasn't been investigated, so there is nothing that helps you, but it would be doing the thing that you ask for. You could control it, but you might want to control it just in this part.
But if it keeps track of the initial flag, so if you did the initial
Yeah.
commit with no overwrite or queue, then it
Yeah,
keeps
then
that.
it
That's
will do
okay,
it,
That's
yeah.
useful. And then the final one is when we're doing various upgrades. So right now we have version 1 of the service. Version 2 might be adding new components, etc. And in a real environment, you might have the services in various stages as well.
Yeah.
What's the maybe recommended way to manage that life cycle, the upgrades? Or
I'm looking at my colleagues here because they are the only one that have investigated any upgrades, but non-converged services. If they are converged, I think it's easier, but I'm not sure. But upgrading in just changing the code of the service and saying that now let's do this, it will be as long as it's just the code, it should just do the work. But when you start changing the declaration part of this service, I actually would like to check that before I answer.
Any other questions for Troy? Right, see one over here.
Thank you. Regarding design and implementation strategy, regardless of the expertise of the people doing the design and implementation, just based on the product functionality, if I have to make a decision today using classic Reactive Fastmap versus Nano Services, what would be would there be a recommendation? And if I have to do Reactive Fastmap, is there a way to facilitate future refactoring with Nano Services?
Yeah, I mean, the lab, which is it's oversimplified, is just that you go from a normal service to a Nano, and also NFVO was an existing released service that went from that to a Nano service. And the only thing here is that if you start to having the requirement that you have the same plan as was the log, it might be a problem for you, because this executes and needs to be something else, maybe, but not necessarily. It depends on that service. So I think that this is so new, so it depends on who you ask. Someone that does Nano Services, I would guess that you guys would say that go for Nano Services now, or at least Nirali. If you have a skill set of doing the normal reactive fastmap, yeah, I would say that you could stick to that as long as you don't have to try to do the most complicated stuff. If you try to invent stage delete, then you probably have the problem that this tries to solve. The easiest way to say, what does Nano Services do? And I usually say that it solves the stage delete. It's sort of boring, small thing, but it's sort of more. It's the life cycle, but that's the hardest part because it's not supported by normal Fastmap.
Okay, thank you. Anything else for a try? Well, we have them up. Okay, here we go.
Yeah.
So it looked like in the behavior definition, the first thing you did was you had a selector that created this self component, and wouldn't that always be required as the first action anyway? And if so, why not implicitly do it, then giving the developer a chance to bundle it?
Yeah, that's right. And but the thing is that you don't need to have just that. Yes.
Thank you.
For very small services, self is enough. You can just stick in a lot of states in between init and ready on self, and you don't have a lot of components, so that's okay. But you still always need that. And there are more of this type in the Nano Services, that small, itchy things that should be fixed or put in next release. You have to do it yourself instead of having help for the moment.
Anything else for try before we go? Oh, one more. Hang on. Let's see if I could have you pass to that gentleman there.
Is it possible for you to explain how this plan thing is synthesized and executed with the help of the transaction? How many transactions are we opening to fulfill this plan?
The most important part here is that the normal Fastmap was possible because how I said we monitor a create call for Fastmap, a normal service. What we do is we start a transaction with the backend, the real transaction that the user use. That's a backend that we read through when we start a new transaction that's empty for the moment. You can just read what's in the open transaction in the back. And then we give that to the create call. So when that comes back, we can see what did you do that was different from what the user did. So that is what the create call did. That's the part. And that needs to be done here, but it actually needs to be done one. There is actually this, and there is a trans in trans in trans. Because in this scenario, as I say, we re-evaluate the behavior. We want to be dynamic. So we might need to reset the transaction sometimes. So it's still the same transaction engine that does everything. And it's a separate service manager that does this. So it looks from the first perspective, it looks like a service because it's a service point. So it goes through the normal service manager and then it says, oh, this is I don't know this. This is a Nano service. And then it defers that call to the Nano service manager that actually does the update, the delete or the create, and in this way.
So That's like the user transaction is the real backend one, and then in the trans you apply all the reverse diff of all the small states, and then you do trans to apply all the state create.
So I can regret and do it again if I choose to, in between. Exactly.
Okay. Thank you. Anything else to try? Any other question? Oh, one more. And Try, you tell me, I know you have another presenter coming up, but
it looks like we could have 50-minute break and then you have 30 minutes, which still is too much for you. And this is the interesting part, because these guys have done something. They actually used it, so then you can ask, was it worth it? And I would know. I would like to know.
Hi, mine is not actually a question, it's a request. Can you add more examples for the Nano Services? I'm looking at 511, the examples with Nano Services. I see the only the template services, so can you add?
Yeah, we should. And that's the thing, that we are doing 2 labs now. That is a Reactive Fastmap lab and a NoNo lab that goes together. They are oversimplified, so I don't know if they will be examples, but then something like that. So sure. Yeah, that has also been lacking, and there is no excuse, actually. Maybe that it was experimental or something.
Anything else to try?
Yeah, we can have another go after your presentation also. Okay, so 15-minute break and then...
Cisco, the bridge to possible.